So today we are going to learn about Apache Spark. Okay. So first, let's talk about what is Apache Spark. Apache Spark is a multi-language engine for executing data engineering, data science, and machine learning tasks on single node or cluster. Okay, so imagine a scenario: you have a huge data set and you want to learn you want to run analytics on that large scale data set. So if you want to do that, so there are few things you need to consider so for this kind of task. So the first one is, if you are doing in a very small single node, it will be very difficult. It will take a huge time. So to do that, the easiest way we do is that we can just run in a distributed compute engine. Okay, or we can call it as a cluster. So we can run it and that, so it can be faster. We can do it easily. That is one. And the second one, it should be fault tolerant. So what if in the middle there is some issue coming there, okay, or somehow some like say your storage is missing, okay, so it's not working in that case. So in that case, how are we going to do that? So that's why we need a framework or something so that can handle all of this thing. Okay, so to handle that, we have actually Apache Spark. So Apache Spark is a unified engine for large scale data analytics. So here if you see like whatever the key feature they're offering, it support batch data and also streaming data also it can ingest. Okay, so it's also support like SQL analytics engine, and also the data frame support is also there. I have not mentioned it here. So and data science, you can do data science at a scale. So exploratory data analysis, you can do it on a petabyte scale of data without having resort or downsampling. That's it can handle it. You have a huge cluster, you can set up it, and if you have a petabyte scale data, you can run your EDA. There is no issue on that. And also machine learning, you can also do that. Okay, it support like different language also, like you have Python, you have SQL support, Scala, Java, R, all the supports are available. Okay, and yeah, it support good ecosystem, like say it has good support about pandas, SQL, and this machine learning library, even SQL analytics engine, if it's just superset, which is another Apache product, Looker, Tableau, Power BI, all these things is supported there. Okay, and from storage side, you have like option for the database like Microsoft SQL Server, MongoDB, Elasticsearch, Kafka, Kubernetes. All these supports are already available. Okay, so let's come back to this PySpark, this notebook. So we'll learn from this notebook itself. So we already I already explained like what is PySpark. So PySpark is a Python API. Mainly PySpark is mainly the Python API for the Apache Spark, and open source distributed compute engine that's provide interference for programming the entire cluster with the implicit data parallelization and fault tolerance. Okay, so this is like yeah, that's the main thing I was talking about. It support data parallelism and also fault tolerances there. Okay, so PySpark allow the data engineer to leverage powers of Python aspect. So simply what you're gonna do, so before starting this one, so you have to make sure Java is set up in your system, Java is installed properly, and Java home, that path variable should be, that environment variable should be connected into your system, otherwise that's not going to work. Okay, even you're writing code in Python itself. Okay, so behind the scene Java is also required. So now let's come to the pip. So you just, how can you install the PySpark? So simple install you can do, pip install PySpark, that is fine. Okay, so or yeah, Google Colab is connected, that is fine. Now we can actually create a session. So to start anything, we have to create one session called PySpark builder .app name, we can pass it. Okay, and simply we can just do that. You can just pass a name of that app and spark some configuration, some value, and get or create, we can do that. And just simply you can just put get or create. If there any existing session is available, it will return it back, otherwise it will create a new one. Okay, so when you run this, so if you see when I'm running this, so we can actually see this COI, it will return like a session. It's a Spark session, in memory session it is created, and it will give one UI access, but though I am running in Colab, so you cannot get the directly access of that. But here you can see the master is local, so it is taking all the cluster, all the all the CPU available here, it will consider that and it is running. That's it. And when you completed your work, so simply you can just write spark.stop, that will do all the stops. Okay, that will done. So now I think now let's come with the data frame. So what is data frame? So as I was talking about, like here when I was again that, like say it support batch data, streaming data, and also you can do SQL analytics. It's also support one more thing called data frame. Okay, so data frame is basically what, now the question is what is data frame. So data frame is basically it's a spreadsheet or a table in a relational. Think about it, just a table. So you have a structured collection of data which is organized in row and columns. So that's a, this is a simple table. And if you're familiar with pandas, you can just think about this as the panda version of Spark. Okay, so and even from the Spark it is easy to convert into panda library. We'll see that you can just easily use that one function, so to panda, it will convert that data frame into panda. Okay, so now the question is why are you going to use data frame. So first one is the scalability. Data frame excel at handling massive data set without fitting in the memory of a single machine. This distributed nature Spark allow to process this data set parallel across the cluster. And performance, it's a Spark Catalyst optimizer play crucial role in optimizing data frame operation. It analyzes your code, generate an efficient plan. Yeah, so this is an important one. So initially it don't, like when you hitting when you executing it, initially it will like analyze your code, then it will generate the plan by itself, and then leveraging the technique like code generation and the query planning, it will do the query planning, everything like how to minimize the data shuffling and improve the performance. Okay, based on that it will generate it. So that is given by default itself. Okay, and the next one is coming schema and data types. It support like it's, you can define schema, which means Spark knows the data types of each column and you can do that. Okay, so it's like type safety you can do, and it is very easy to use. Okay, so let's do one thing. Let's create a data frame. So you can just create data frame from different sources, different way. So first one is like you can just create list, your tuple or dictionary, that will be that will save the data in memory data. You can do that. So for example here I'm creating data list tuple dictionary in memory database. So PySpark possible, like data frame like Python object, from there you can just create it in memory. This data frame is the in-memory structure. You can initialize a Spark session and provide the data to the list and tuple and specify the column. So that's it. So for example here, this is my data. If I run it, I'm just creating a list of tuples. Okay, so I'm just creating a list of tuples and giving the data and also giving the list name of columns. So from that it will figure it out. It is the name and age. So this way I can create it. And if I want to see the schema of that, you can see the schema is also created. So name, it is the string, and age, it's by default it's figured out long only, but yeah, you can actually control that also. Okay, so there is some helper method available. You can use df.head. So df.head will basically give you the top data, the first one, and you can just use tail and 5, and you can pass some value only, like from the end how many data you want. Okay, so if you want 5, so it will, though we don't have 5 data, so it is giving the entire data set. Okay, so even you can create it from dictionary. So if you are creating from dictionary, you don't need to like explicitly give the column names. It can automatically figure it from there. That's so fine. And you can also use a row itself. Okay, so you can like use the row object itself for more complex structure if you want to use it. So that's also gonna work. If I run it, yep, this is going to work. Okay, so few more things. Now I think we have seen like from using the list, tuple and dictionary. So how you gonna do that? But there is something we call CSV file. Okay, so you can directly import CSV file, parquet file. All this file also supported. So here what I'll do, we'll just import a parquet file. Okay, so let's see here, we don't have the data. So we'll run this one. This is all link, and using the using this command we'll download it. Okay, it is 54 megabytes of file. Okay, yeah, it is 45, yeah, 45 megabytes of the data. Okay, so let's load it, this one. Yeah, so it's loaded automatically. This is good. So if you can, we just read a simply like parquet file, and thus you can give the file path, and from file path, it created the data frame, and you can just print the schema. You can see this is the schema we have, all the data types it is written, and we want to see the like top 5 data. So you can see it like this one. We have passenger count, trip distance, record ID, store field, amount, total amounts, lot of things we have it. Okay, now if I want to see like how many columns we have total 19 columns. Okay, so here all the columns details you can see that, and if you click the data types, it will print all the data types for every columns in the data frame. Okay, and you can use this command called describe.show. so what it will do, for every column it will give you count, so you can see like is there any null value is available or not. So using that count you will get the mean value there, and also standard deviation you can also get it, minimum value and maximum value also you can get it here. So for example here this one, so payment fare amount. Okay, for fare amount some amount 900 minimum and maximum in 1160.1. okay, so the tax MTA tax or trip amount total maximum is 380. okay, so and you can see this is the mean value. If you go for minimum value is going to be trip amount is 3 point something. okay, that's the way. And if you want some more statistics, you can just get it summary.show. so summary what it will do, it will count, it will mean standard deviation, minimum, maximum, 25 percentile, 50 percentile and 75 percentile. it will give you the data. okay, so this way we can also take some decision when you're doing any EDA. So now let's come